Let's say I've been asked to sketch the ellipse given by x is equal to 1/3 cos theta and y is equal to 4 sine theta. Okay, so what I can do is I can rewrite both of these equations as cos theta equals and sine theta equals. So cos theta is equal to 3x and sine theta is equal to y over 4. Okay, and then you can substitute them into sine squared plus cos squared equals 1. So we get y over 4 squared is sine squared plus cos squared equals 1. Okay, and then I can expand these brackets out. So we get y squared over 16 plus 9x squared is equal to 1. Okay, so when x equals 0, okay, when x is 0, you can cover up that bracket there, or that term there, and you can get y squared over 16 is equal to 1. So you can multiply both sides by the 16, and then square root both sides, and you get plus or minus 4. So we're going to have 0, 4, and 0 minus 4 and 0, 4, okay, as where it crosses the y-axis. And when y is 0, so if we cover up this term here, we can divide both sides by 9 and then square root both sides, and so you would get minus 1/3, 0, and 1/3, 0. Okay, and that tells you where the ellipse is crossing the x-axis and the y-axis. So you can then go straight in with a sketch. So it's going to be more elongated in the y direction because it's going through minus 4 and 4 as opposed to minus 1/3 and 1/3. So to try and get this fairly symmetrical, okay, let's see how this goes. It's going to be quite long and thin. Doesn't need to be perfect, okay, that's far from perfect, but as long as you are identifying the important points and clear that it is fairly elliptical, then you have your curve. And what you should be able to identify here is that maybe you could have gone straight from the equations, parametric equations, to the curve in question, because you can see that this is crossing through 1/3 and minus 1/3, okay? So as theta varies, I mean for cosine or sine, if you think about it, so for cosine and sine, in both of these cases, as theta changes, so let's say that's the theta axis, the only values you can get are between -1 and 1. So the largest value of this is 1/3, and the smallest value is minus 1/3. The largest value of this would be 4, and the smallest value is minus 4. And so that tells you instinctively where it must cross the x and y axis. So you can go through this approach to get the Cartesian equation and then to find the coordinates, because it's fairly straightforward from there how to do it. But you can go from the parametric straight to the ellipse as well, and some of you may find that easier.